Alright, in the last video we talked about finding trig ratios and just using the table. So you would match up, you would follow all these rules. Now this one's pretty cool because this one you don't need to memorize a whole table of information to actually get there. You just need to memorize this little fact, okay? Now we've already pointed out that x is cosine of theta and sine is y. Sine of theta is y. Okay, and we've already pointed out that the coordinates that cosine when it's 0 is 1 and cosine when it's 90 is 0. Okay, and sine of 0 is 0 and cosine of 90 is 1. So here's a little pattern that you can memorize. So if you start down at the very bottom and start at the square root of 4 over 4 for cosine and you count your way down, so from 4 over 4 to 3 over 4 to 2 over 4 to 1 over 4 to 0 over 4, and you use the square root and then you simplify it the best you can, you can actually find the ratios for cosine that way. And then because they're co-functions, sine's going to start up here at the square root of 4 over 4, the square root of 3 over 4 up here, and it's going to count down this way, which makes sense because, oops, no, not 2 over 2, 2 over 4, and then the square root of 1 over 4, and then the square root of 0 over 4. Okay? And so that's going to be the coordinates for how you work this stuff out. So this is actually kind of cool because if you notice, this simplifies to 0. This simplifies to 1/2. Okay, this actually doesn't simplify very much. It just simplifies the bottom. So we still have the square root of 2 divided by 2. This doesn't simplify very much. This actually just is the square root of 3 divided by 2. And this one just turns into 1. Okay, so that one's pretty simple. But that actually follows the values because cosine of 0 is 1, cosine of 30 is root 3 over 2, cosine of 45 is root 2 over 2, cosine of 60 is 1/2, and cosine of 90 is 0, which matches our information from earlier. If you take a look at it, it's really kind of cool. Root 3 over 2, root 2 over 2, 1 over 2. So it's actually really cool how it works. Okay. All right, now if we go the other direction, this turns into 0. This turns into 1/2. This is root 2 over 2, root 3 over 2, and 1. And that follows the pattern for sine. Okay, and they're like two passing ships in the night. It's really kind of cool how it works. Now I had a fellow teacher of mine notice this, and she pointed it out as we went, and it was like, oh my gosh, that's really nice. So cosine of theta and sine of theta. Okay, and let's say we had theta over here is another value. Okay. And so if we have them line up, you'll see this pattern a little bit more clearly. And these are going to be the main ones. And this is kind of cool because you can still use your reference circle for this, okay? So this is going to be the square root of 4 over 4, which is 1. This is going to be root 3 over 2. This is going to be root 2 over 2. This is going to be 1/2. And this is going to turn into 0. Okay, and then the way that this went down, and this is really kind of cool how this all works, and I wanted to make sure I took time for this. So this is counting down for cosine. As you go higher in angle value, it's going to be going the opposite direction for sine. It's going to be going up. Okay? Well, counting down, going up. You know what I'm saying. So this is going to start at 1. This is going to be root 3 over 2. This one's going to be root 2 over 2. This is going to be 1/2, and this is going to be the 0. And as you can see, it follows the co-function just very nicely. Now to find tangent, obviously you just take sine and cosine and divide them, or you can just divide these two numbers and just work with it that way. It's totally up to you. And then for cosecant and secant, what you would do is you just reciprocate sine for cosecant, you would reciprocate cosine for secant, and you would reciprocate tangent for cotangent. Or you could use this formula right here and just find the points. Okay. There's also, I'm going to be saving to the message board a document with the unit circle and everything and sending it out to everyone. But I just wanted you guys to be able to see this because it's really cool how it works. Okay. All right. Thank you very much and have a great day. Bye.